You're listening to the FQXI podcast. Today,
what's fascinating about a poltergeist case is that it does involve a physical interaction. It may involve furniture moving, it may involve somebody levitating, it may involve fire starting, strange electrical behavior, lights going off, light bulbs breaking, floods and all sorts of things. And that's what's to me so fascinating, because if it involves an interaction with the physical world, that means physics has got to be able to explain these things, if physics at least is going to be complete.
poltergeist and primordial black holes.
So when we were at Caltech together in 1975, the great hope was that we would be able to see one of these black holes exploding as a gamma ray burst. Because if that had been happening, it would, one, prove primordial black holes existed, and two, it would prove that Hawking radiation was correct. And so now the interest is, well, what else can these big black holes do? Can they, in particular, provide the dark matter?
Cosmologist and part-time psychical researcher Bernard Carr talks about working with Stephen Hawking and investigating the paranormal, telepathy, astral projection, and haunted houses.
And I've always felt that what fascinates me about psychical research is that it sort of forms a bridge between science and spirituality, because psychical research is trying to study scientifically those phenomena which are in the mental or spiritual domain.
I'm Zeeya Merali. Welcome to the podcast from the Foundational Questions Institute. It's Halloween, so I thought now is a good time to share a fascinating interview that I carried out with cosmologist Bernard Carr, Emeritus Professor at Queen Mary University of London in the UK. Carr was once a student with Stephen Hawking and made a name for himself in black hole research, and as an early champion of the multiverse, the idea that our universe is one of many, and its relationship to solving the fine-tuning problem of physics, the puzzle of why so many of nature's constants seem to be tuned to the perfect values to allow intelligent life to evolve. But in parallel to his illustrious career in physics over the past 50 years, Carr has also been studying aspects of the paranormal that lie beyond mainstream science, using the scientific method to probe telepathy, astral projection, and to visit haunted houses to assess evidence of ghostly visitations. That includes the notorious 1970s case of the Enfield Poltergeist, involving allegedly weird occurrences at a house in North London. If you have seen the second movie in the Conjuring franchise, then you will be very familiar with this story. I should say, I have some personal fondness for this tale too, because I'm from Enfield. In this edition, you'll hear the first part of my interview with Bernard Carr, weaving between his work on the natural, the supernatural, and the mystical, including the Enfield haunting. Hello, Bernard Carr.
Hello, Zeeya. Delightful to see you again.
Thank you very, very much for talking to me. We were just saying before we started recording, we haven't seen each other since the last FQXI international meeting in Italy a few years ago. So I'm very, very pleased to get you back here again. I've interviewed you in the past. I've chatted to you for a long time, and I know about some very, very interesting physics work that you do on black holes and tiny, tiny primordial black holes that were created in the early universe, or may have been, hypothetically. And so I've wanted to talk to you about that for a very long time. But the reason I actually reached out and managed to sort of contact you again after a few years was because I was watching a program on Apple, a documentary called The Enfield Poltergeist. And I should say I'm from Enfield, which is a little town in North London. And so for people who don't know this story, it's something that people from Enfield know all about, which is that in the 1970s, there was a very well-publicized account of poltergeist activity, which has kind of gone down in history because I think it may or may not be one of the best established accounts of poltergeist activity in the world. there's all kinds of skepticism around it, but also it has never really been fully debunked. And so there was
attracted a lot of attention, and there have been various movies made about it, as well as many documentaries.
I've seen them. I love them. And so I sat down to watch this documentary, and nothing to do with FQXI, nothing to do with the podcast, just for my own interest. And I can't remember which episode it was, but a very well-produced documentary. They wanted to speak to scientists who were investigating there at the time. And I heard the voice of one of the interviewees, and I thought, I recognise that voice. And then up popped Bernard Carr. And I thought, oh my goodness, I had no idea that as well as being a very famous physicist, as well as having done all of this work on black holes, and we'll be talking about that soon, as well as having studied with Stephen Hawking, really being very well known as a physicist, suddenly I'm seeing you on television talking about a haunted house, talking about poltergeists, and talking about your involvement going back to the 1970s with this psychical research. And, I immediately got in touch with you to say that I'd seen you there. And you sent me a really interesting piece about your very long-standing history with this area of research. And I now know that actually you have a diverse range of interests, spanning from physics to psychical research to perhaps the more spiritual, perhaps the more mystical side of things. And over the past 50 years, you have been following all these lines in parallel and sometimes overlapping these strands and trying to tie them all together in a way that's highly unusual, but I think completely fascinating. And I'm going to ask you about all of those.
Well, Zeeya, thank you. That's a most interesting introduction. And I should say that you're quite right that most of our previous interactions have been in the context of mainstream physics conferences, such as the FQXI meetings. And normally in those meetings, I'm really rather discreet about my interest in other matters because, by and large, physicists want to focus on what they see as respectable mainstream physics. So I'm often reluctant to talk about my other interests, which you've referred to, in the context of mainstream physics, just because most of my physics friends and colleagues are somewhat skeptical of those other areas. But you're quite right. It's been my secret passion for at least 50 years, these other subjects. And so you've discovered this. And I'm happy to talk to you because I'm now retired. I'm an emeritus professor at Queen Mary University of London. So I can now be much more open without getting into trouble with my colleagues. I'll be very happy, if you like, to explain why I'm interested in these different areas.
Absolutely, because, this isn't common amongst physicists, or if it is, it's in secret. We don't tend to hear about it, as you say. So how did this start? And I have some sympathy towards your line of thinking. I think that maybe all three of these passions of yours have a common root, but maybe they don't. Maybe they have three different roots. Tell me, when did you first become interested in physics, in psychical research, in the sort of the more mystical side?
Well, I can actually answer that question rather precisely because it really all goes back to when I was at school. I was at a boarding school called Harrow. On one occasion, I'd misbehaved and I was confined to my room apart from lessons. So I had nothing else to do except to read some books. And I read 3 books. There was the ABC of Relativity by Bertrand Russell, and that got me interested in space and time and physics. I was about 15 when this happened. The second book I read, it was called An Experiment with Time by J.W. Dunn. And this was a book in which he recorded his various apparently precognitive dreams and the theory of time which he developed in order to explain them. And that got me interested in, precognition and more generally those phenomena, psychical phenomena, which are rather contentious. The third book I read, it was called The Third Eye by someone called Rob Samper, who was allegedly a Tibetan Lama who had sort of taken over the body of a Cornish fisherman. And he was talking about all his mystical experiences as a Tibetan Lama. Now, actually, I'm rather skeptical now about it, the Cornish fisherman's claim. Nevertheless, it got me interested in the links between religious theory and psychical phenomena. So really, those 3 books initiated my passion, really, in those 3 subjects, in science, psychical research, and mysticism, if you like, which have really lasted ever since.
And at that time, did you think of them as three separate strands of research, or did you think of them as one unified thing that maybe was manifesting in three different ways?
Well, that's the interesting point because actually I became convinced they were linked. And it became my sort of passion that I wanted to expand physics to accommodate psychic phenomena and indeed spiritual experience. Not just psychic phenomena, which is a very controversial field. I wanted to expand physics to accommodate mind. There's a problem even accommodating normal mind, quite apart from paranormal mind, into physics. But this is what I wanted to do. I wanted to connect these three areas.
So this was when you were a schoolboy at Harrow. You did an undergraduate degree in maths at Cambridge before embarking on a PhD with Stephen Hawking. Did you put your psychical interests aside at that point, or were you keeping those going in parallel?
When I went up to Cambridge as an undergraduate, I immediately joined the Cambridge Astronomical Society, the Cambridge Society for Psychical Research, and the Cambridge Buddhist Society, where I took up meditation and things. I was studying mathematics, but to be honest, I was spending more time actually in these other activities than my official studies.
Did you ever think about studying psychical research more formally? I don't even know if that is something that can be done.
When I finished my undergraduate degree, I had to decide what I was going to do. I wanted to do a PhD, and I was torn between doing a PhD essentially in cosmology and parapsychology. I mean, I knew I couldn't get a job as a Buddhist because I wasn't sufficiently devoted. I mean, some of my friends did become Buddhists and they became monks and devoted their lives to the spiritual path. But I realized that wasn't my way, even though I was interested in the subject. And at the time, there were no positions in parapsychology. There was a group in Edinburgh led by someone called John Beloff. And I did go and spend a summer with him to see if I was interested in doing a PhD. But in the end, I was advised that there was little career prospects in parapsychology. I was advised the best thing to do would be to establish myself in a more respectable field. Then when I become at least semi-respectable, I could then start talking about parapsychology from a positive point of view.
And this is where Stephen Hawking and black holes come in.
I decided to do my PhD, and I was very lucky because I did my PhD with Stephen Hawking. He wasn't quite so famous in those days. He'd not written his famous book, but everyone knew he was a brilliant physicist. I started working with him in 1972 and finished my PhD in 75. So that encompassed the period when he came up with Hawking radiation, perhaps one of his most important discoveries, and I would say one of the most important discoveries in physics of the sort of late 20th century.
Just to interject here about Hawking radiation, previously when physicists thought about black holes, they assumed that nothing that crosses a black hole's event horizon can escape, not even light, hence them being black. But Hawking's famous realization was that particles can radiate from the surface when you take into account quantum effects.
I was very lucky. That got my professional career off to a good start, if you like. And I maintained my interest in these other areas, in psychical research, and indeed in spiritual matters, if you like. But most of my time, of course, was being spent on my mainstream activities in cosmology.
You're zooming through your life, and I appreciate it was a long time ago, but there's so many interesting things to pick you up on before we even get into your work with Stephen Hawking. And that's because, doing some reading about you, I realised that you had already started as a school child doing some experiments into psychical research yourself. And I wanted to ask you a little bit about that, first of all. What were you doing at school? Because you're already thinking in a very scientific way about these ideas. So what sort of experiments were you doing with your classmates?
Well, the first experiments I did at Harrow, I got some of my fellow school boys, about 100 people in fact, to record their dreams over a period of a week. And the idea was to see whether people had shared dreams. Person A might dream of person B and B might dream of A in the same circumstances. Now, if that was true, that would be evidence of what we call telepathy, the idea that there can be direct communication with minds. Of course, the existence of telepathy is controversial among many of my mainstream colleagues, but I think there is good evidence for telepathy. And so other possibilities was we had what I called indirect telepathy, where person A dreams of person C and person B dreams of person C in the same circumstances. And it lasted a week, and I got lots of data. And there did seem to be examples in which people were having shared dreams. Now, I have to say, in retrospect, I don't regard this as a very good experiment because people could collude, and you might think especially naughty school children would collude because people could coordinate what they write down. However, I did claim at the time that we had positive results. As it happens, I was an editor of the school magazine at the time, the Harrovian, and I even wrote an article claiming indisputable proof of telepathy. I think now that was a little bit optimistic, but that was the first experiment I did, and that was at Harrow.
You also had some early experiments on astral projection?
When I went to Cambridge, I joined the Cambridge University Society for Psychic Research, and we did lots of experiments there. I had developed an interest even before going to Cambridge in what we call out of body experiences. This is when people, their consciousness seems to leave their physical body and they wander around in the outside world and have experiences. But the key thing is they don't seem to be in their bodies. Now, of course, this is another controversial phenomena, but I became fascinated in that because it implied that in some sense consciousness wasn't just something locked into the brain, if you could somehow escape from your physical body. And I read many books on the subjects, and I tried to induce out of body experiences for myself. And actually, I had some success. On one occasion, I did find myself, I was in bed at home, and I found myself in the sitting room of the house. But I found that very scary, of course, even though that's what I wanted to achieve. I found it very scary. So that put me off for a while in out of body experiences. I mean, obviously, one could just say it was all an imagination, but nevertheless, I was fascinated in the subject. And when I got to Cambridge, one of the things I did at the end of my first year was to do some experiments to see if I could weigh people when they were having out of body experiences. Because the idea would be that if you really were having an out of body experience, and if you really were in what was called an astral body, well, maybe that astral body might weigh something. And therefore, you could try and see whether the weight of the physical body went down when they had an out of body experience and then went up again when they came back. And so that was one of the first experiments I did in Cambridge. Now, it was all triggered by some reports going back some way that when people died, their weight went down by a few ounces. And therefore, I was thinking, well, therefore, maybe the astral body, or whatever you want to call it, also weighs a few ounces. I don't think the original measurements, death variation, were very convincing because your body weight tends to change anyway, when you die for various reasons. But anyway, that motivated the experiments. The basis could be completely wrong. It may be that there's no such thing as an astral body. Even if there is, it may not have weight. And even if it does, you can't infer that the astral body is going to leave your physical body every time you fall asleep. But that was the experiment. And I did it over a course of a week. Some of my friends took part. And again, I even claimed, on some occasions, I did claim to get results in which the body weight did seem to go down a little bit, and then it went up again when they woke up. But to be honest, the experimental apparatus was rather crude. I did it at Addenbrooke's Hospital. And in retrospect, I don't really think that the experiments were very convincing, and I never actually published them formally. However, a lot of my friends at Cambridge still remember me as the person who weighed their soul. So it was probably one of my more memorable experiments.
So, one quick question about that, and then one maybe deeper question. The first quick question is that you said that you had managed to induce an out of body experience in yourself. Maybe it's a dangerous question to ask, but how does one do that?
Oh, well, there were various techniques which people were suggesting. I mean, often it's a matter of visualization. Even the process of reading about the topic, if you're reading about having out of body experiences, that might induce dreams in which you're having out of body experiences. So I won't go into the technicalities of specific techniques because that would be quite a long involved subject. But one of the symptoms is that you experience sleep paralysis. Sleep paralysis is when you wake up and you can't move your physical body. Well, that's a well-established phenomena, but some people claim that sleep paralysis is related to out-of-body experiences, and that I think I found in my own experience. I have to say that although I deliberately tried to avoid out-of-body experiences for a while, later on I took up meditation, things like that, and I found I started having the experiences more regularly. I still have lucid dreams on a regular basis. And I still experience altered states of consciousness, if you like, in lucid dreams. And I would claim to have even had sort of telepathic and precognitive experiences. And I realize that some of my more down to earth physics colleagues will be skeptical about that. And, I'm not going to claim absolutely that this is definitive proof. If they want to say it's all an illusion or that I'm a bit crazy, that's fine. But at least it convinces me enough, if you like, there's another level of reality that goes beyond ordinary material reality, that there are other modes of levels of consciousness, of communication, if you like, between minds, which aren't yet acknowledged by mainstream science.
I don't know if you know this, but cosmologist Andre Linde started in cosmology because he had an interest in telepathy.
Well, I know Andre well. We meet at many conferences and talk about inflation and black holes and things. I never knew he was interested in telepathy. However, I did know he was interested in consciousness.
Yes.
Because he even wrote in one of his books once that he thought that a final theory of physics should accommodate consciousness. And that really is actually my fundamental position as well. That even if you don't believe in psychic phenomena and even if you don't believe in mystical experiences, one has to accept that consciousness is a fundamental aspect of the universe. The point is, physics has been triumphant in coming to understand the physical world on all scales, from the very smallest scales of the Planck length, 10 to the minus 3 centimeters, all the way up to the scale of the observable universe, which is 10 to the 27 centimeters. However, from my perspective, it's, if you like, it's the triumph of mindlessness. Okay, because there's no reference to mind. Whereas, as many people nowadays are very interested in mindfulness, if you're into meditation and things like that. And I think there is good evidence that consciousness interacts with the physical world. I mean, it clearly interacts through the brain, which we don't understand anyway, but I think it can interact with the physical world in other ways, which, if you like, are studied by psychical research. Now, that's not always a popular view. I mean, physicists often don't believe the phenomena I'm interested in. And even the people who believe in the phenomena, the more mystical people, they don't necessarily want to be associated with physics because they think that's too reductionist and things. But nevertheless, I think it's really crucial. And I've always felt that what fascinates me about psychical research is that it sort of forms a bridge between science and spirituality. Because psychical research is trying to study scientifically those phenomena which are in the mental or spiritual domain. And when the Society for Psychical Research was founded in 1882, it was set up precisely to investigate in a scientific manner those phenomena which weren't currently understood. And so that's why I just feel you have to build a bridge between science and spirituality, even if that's not popular. But that involves an expansion of science and, in particular, physics. And you also have to expand your concept of spirituality so they can meet in the middle.
You've alluded to the fact that you can say this now openly because you've retired and you can be more open about your various passions. But the things that you were doing when you went up to Cambridge in terms of the out-of-body experiences and those kinds of experiments, you mentioned that you were doing experiments at Addenbrooke's, and this is a very well-respected hospital in Cambridge. It's a very famous hospital in the UK. Obviously, Cambridge University is an incredibly well-respected university, possibly the most respected university in the world. You're working with Stephen Hawking, who already was establishing himself as one of the greatest minds in physics. At that time, how secretive were you about what you were doing? What did your friends in physics think about the experiments that you were trying to do at Addenbrooke's? How did Addenbrooke's agree to let you do these experiments? I can't imagine when I was at Cambridge that I could have done that. What did Stephen Hawking think? Did he just kind of laugh, or was he really, really interested, or did he not know about it?
Well, the experiments I've talked about so far, including those experiments at Addenbrooke's, they were done before I began my PhD with Stephen. I didn't meet Stephen until 1972, and these experiments were done just before that. You mentioned earlier, how did I get permission from Addenbrooke's Hospital? And, well, I don't know who I asked now I come to think about it. It was a long time ago, but I suppose someone said, well, he's at university, he must be respectable. honestly remember. But of course, when I started working with Stephen, he knew about my interests and we talked about that, although we mainly talked about black holes and cosmology. Now, I should say he was skeptical. He had read as a teenager one of the books by J.B. Ryan, who was the person who sort of started experimental parapsychology in the United States in the 1930s. But he was not convinced by that. So he was rather skeptical about psychic phenomena. But more important than that, he certainly did not share my enthusiasm for expanding physics to accommodate consciousness and spiritual phenomena. Stephen, as you know, he was rather opposed to philosophy and especially theologians. He was a brilliant physicist and he wanted to reduce everything to a final theory of physics. And he knew about my interests, but he didn't share them, nor did I ever really try and persuade him that he should be interested. I mean, Stephen was a brilliant physicist, and I had no desire to try and convince him that he should get into meditation or anything like that, or thinking about psychic phenomena, because that would have distracted him from his prime purpose in life. And actually, it's the same with all my physics colleagues, because the normal argument is that when you confront a skeptic, you say, well, you should read the literature and then you'll believe it. Or you should talk to people with experience and then you'll believe in these phenomena. But the reason I'm interested in these phenomena, I suppose, is because I've had experiences. I'm certainly not very psychic and very spiritually evolved, but I have at least had enough experiences to convince me that there is a level of reality that needs to be accommodated. People who've not got those experiences won't have the same motivation. So I've never felt any need to convert my physics colleagues into an interest in these phenomena, and it doesn't bother me if they're skeptical. I only get annoyed when people who know nothing about the subject and have never had any experience claim it must be wrong, it's all rubbish. They don't have to look at the data because they know it can't be right, because they know it can't be compatible with physics. And that's what annoys me because, I mean, I find that argument completely bogus. It may not be explicable by current physics, being essentially quantum theory and relativity theory, but we know that's not the final theory of physics. We know the final theory of physics is going to marry up relativity theory and quantum theory. And we don't quite know what that final theory of physics is. But we certainly can't say that these phenomena are incompatible with physics because we don't know what the final theory is yet. And of course, there are plenty of other physicists, a minority, but people like Roger Penrose, who do think that the final theory of physics should have some reference to consciousness.
I appreciate that you didn't want to waste your colleagues' time with these discussions or try to convert them to becoming psychical researchers or to believe in these phenomena themselves. But at the same time, I'm wondering, was part of the reason you were quiet that you were worried that they would look down on you for your beliefs and interests if you were more open about them?
So it is also true that there were reasons why one had to be quite discreet, because certain subjects, in particular parapsychology, were essentially taboo, are essentially taboo, I should say. They're regarded as heretical. And even to be interested in psychical research, it can be a black mark in some quarters. I think undoubtedly my career might have suffered. I wouldn't have got research grants. I might not have got promoted and things like that. And so that was also a factor. And now I'm retired, I don't have to worry about my professional standing because they'll say, oh, he's crazy now. But people go crazy when they retire. So they don't know if I was crazy now. I was crazy all those 50 years ago when I started. However, having said that, of course, my friends within physics know about my interests. And some of them share it, and others are just politely tolerant of them. And one has to realize that although I keep talking about mainstream physics as not accepting these phenomena, there is a subset of physicists who are interested, and some of them are very eminent physicists too. On the other hand, when you talk about that, you have to differentiate between the sort of different levels. For example, I talked about the fact that psychical research or parapsychology is a taboo subject. But there are many other taboo subjects. Consciousness itself was a taboo subject 20 years ago. Physicists would not talk about consciousness because it was regarded as something to do with, well, philosophy or psychology or something like that. But now, actually, it's respectable because of developments in neuroscience and, of course, certain interpretations of quantum theory. I think you have to appreciate that there is evolution of what is heretical in physics in particular. I mean, I can give you another example, the anthropic principle.
That's just to explain, that's an explanation for why so many of the physical constants in nature seem coincidentally and serendipitously to be fine tuned for intelligent life to exist. And in recent years, the anthropic principle has been related to the multiverse, saying that actually other universes exist, each with different physical parameters, and since obviously intelligent life can only arise in universes that are habitable, there's no massive mystery to the fact that we do find ourselves in one of the universes with the right parameters for life.
The anthropic principle is something I worked on, not with Stephen so much, just with Martin Rees, but way back starting in the late 1970s. The idea there are these fine tunings, and that these fine tunings of the physical constants are necessary for life. Now, when I first wrote about that with Martin Rees, we wrote a big review in Nature in 1979. It was regarded as very heretical. Again, it was many of our physics colleagues rejected this as philosophy or even theology. Nevertheless, there was no doubt there are these fine tunings that have to be explained. However, now, 40 odd years later, you can really begin to talk about the anthropic principle. You can use what used to be called the A word to avoid getting. And the reason for that is because we now have a sort of a possible physical basis for understanding the anthropic principle based on the idea of the multiverse, the idea that there are lots of different universes with different constants, and we necessarily have to be in one of the universes where the constants are right for life. That's made the subject more respectable. Now, of course, even the multiverse is regarded as philosophy among some physicists, so that's still controversial. But on the other hand, many famous physicists, such as Stephen Hawking himself and Steven Weinberg and Len Susskind and Martin Rees, of course, now do take the idea of the multiverse seriously. So that's another example of something which 40 years ago was taboo, but is now respectable. So I take the view that there are trends in physics, and what is regarded as beyond legitimate physics or even heretical at one time may later become respectable. So I like to think that eventually these more extreme controversial topics that would come under the general heading of psychical research and even mystical experience will also one day be regarded as a more respectable domain of discussion.
Well, let's talk now about the years with Stephen Hawking and your work on primordial black holes, which is not controversial or heretical in the way that the psychical research is, or even the way that the anthropic principle was. But at the same time, it's still an unusual area to have an interest in because primordial black holes are, they've sort of gone in and out of fashion. And I think as we talk about your life, we'll talk about how they've dipped in and out of fashion. Let's just start with an explanation of what a black hole is and the different types of black holes that people think or at that time thought could exist, and what were the sort of the more hypothetical types of black holes.
Okay. Well, when Einstein came up with his theory of general relativity in 1915, it was soon realized just a year later that there was a particular solution called the Schwarzschild solution. But this had the strange feature that if you have an object which was compressed too much, then it would form a black hole in the sense that no light could ever escape. And actually, this concept goes back to Newtonian gravity, even because in Newton's theory, you've got the concept of the escape velocities. You need a certain velocity to escape to infinity to escape the gravitational field. And that escape velocity, even within Newtonian theory, will exceed the speed of light if your body is too compressed. That was recognized indeed by Michel, the famous Englishman, hundreds of years before Einstein came along. But of course, Einstein's theory of gravity was somewhat different, but it did have the same prediction. If a mass falls within a certain radius, it forms a black hole in the sense that light can never escape. It's called the Schwarzschild radius, which is predicted by Newton's theory. Now, despite that, many people didn't take the ideas of black holes seriously. Einstein himself didn't believe in black holes, and nor did Eddington, who was his primary champion, because although in theory this could happen, it wasn't clear it could ever happen in the real universe. However, in the 1940s, it was realized on theoretical grounds that a collapsing star could produce such an object. This was discovered by Oppenheimer and Volkoff. And then in the 1960s, they started discovering there really were black holes, which are the results of stellar collapse in the real universe. They were discovered through X-ray observations. And so now we know, even in our galaxy, that there's several billion black holes. And also, I should have mentioned the clinching evidence came with the discovery of the gravitational waves, 2016, when LIGO Virgo experiment, it detected the gravitational waves from two black holes which were merging. That was definitive evidence, not only for gravitational waves, but also for these big black holes which had formed from stellar collapse. And so now there's no doubt about that. But at the same time, people also got interested in much larger black holes, what are called supermassive black holes, because they discovered quasars in the 1960s. And the quasars, they're tremendously luminous. They're at the edge of the universe. They're brighter than an entire galaxy. The reason we now know is because at the centers of the galaxies are supermassive black holes. And these supermassive black holes are associated with very energetic phenomena. And the masses of these black holes varies from anything from a million, like our galaxy, for example, has a 4 million solar mass black hole in the middle. Now we go all the way up to several tens of billions of solar masses. So it's now pretty uncontroversial that probably all galaxies have got big black holes in the centers.
So we have these black holes that we know exist, ones that are really well understood theoretically, which are the ones that arise from stars exploding and collapsing and creating black holes. And then we have these supermassive black holes where we're pretty sure they exist, but we perhaps don't understand the mechanisms behind how they are created as well.
So those are the two contexts in which we know for sure that black holes do exist.
And so now let's go back to the 1970s and you and Stephen Hawking thinking about a different type of black hole, a primordial black hole. So what is that?
Well, first of all, this is all based on the assumption that the universe did start with a Big Bang, which is the mainstream view now, about 14 billion years ago in a state of great compression. And actually, it was Stephen in 1971, he realized that if the universe was very, very compressed, that in principle you could form small black holes. And the reason is as follows. I mentioned the Schwarzschild radius, which goes like the mass. It's proportional to the mass. Okay, it's very small. For the sun, it would be a few kilometers. The sun is much bigger than that, which is why the sun isn't a black hole. However, if you think about it, the density required to form a black hole, it goes like the mass over the volume, which is the mass over the radius cubed, which is therefore inversely proportional to the mass squared. So the density required to form the black hole goes like 1 over the mass squared. So the smaller the black hole in mass, the bigger the density required. Now, in the present epoch, you can't form any black hole smaller than the mass of the sun because you couldn't attain that density. On the other hand, these supermassive black holes in the middle of galaxies, they're very massive, so their density isn't very high at all. The black hole in the center of our galaxy, the density would only be something like the density of water or something like that. But now these primordial black holes, they are much smaller than a solar mass. They require a much higher density. But the point is that in the Big Bang theory, the density becomes arbitrarily high as you go back to t equals 0. In theory, at t equals 0, the density becomes infinite. And so Stephen realized that in principle, you could form a black hole of arbitrarily small mass if you go back to early times. And in fact, the mass of a black hole, which forms a time t after the Big Bang, is just what's called the mass within the horizon, the distance light has traveled at time t. So there's a very simple formula for the mass of the black hole in terms of the time at which it forms after the Big Bang. So, for example, if a black hole formed at about 10 to the minus 5 seconds after the Big Bang, which is what's called the QCD epoch, then it would have a mass of about a solar mass, the mass of the sun. But if it formed earlier than that, it would have a much smaller mass. And in principle, you could go all the way back to what's called the Planck time, which is 10 to the minus 43 seconds, which is the earliest time at which really you can apply relativity theory. That's when quantum gravity effects come in. And the black hole which forms then would have a mass of 10 to the minus 5 grams, which is called the Planck mass. So you could have black holes going all the way from 10 to the minus 5 grams, all the way up to the sort of astrophysical mass black holes. And for example, a black hole forming at 1 second would have 100,000 solar masses, comparable to the mass of the black holes in a galaxy. And so Stephen realized this, and he wrote a paper about this way back in 1971, before I actually began my PhD. And so he actually talked about black holes having something like the Planck mass, and he thought they would be charged, and he thought they would attract an electron or a proton and form a sort of neutral atom. And then he thought these atoms could sort of get swallowed by the sun, for example, and this could explain the solar neutrino flux. Well, some aspects of that model turned out to be wrong because we don't think they will be charged. But nevertheless, the basic idea that you could form small black holes in the early universe, that goes back to 1971. Actually, even before that, some Russian physicists called Zeldovich and Novikov had argued that primordial black holes couldn't exist because they thought they would just accrete because of the high density. They thought they would grow very rapidly and they would grow to gigantic sizes today, which would be incompatible with observation. Now, when I began my PhD with Stephen in 1972, he got me to work on this problem of whether black holes, these small black holes, really would accrete in the way the Russians had said. And we were looking at the exact Einstein equation, so we were doing a more precise calculation rather than the rather heuristic one the Russians had done. And we were able to show black holes wouldn't grow at all. And we published this paper in 1974, which basically showed that primordial black holes could exist, they wouldn't grow very much at all, and therefore there was no reason to exclude them. So that was the first paper I ever wrote. I wrote it with Stephen, and actually it's my most cited paper. So ironically, in terms of citations, my career has been downhill from the start. Because this is, my very first paper was the most cited one ever. That was important, though, because it more or less put PBHs on, primordial black holes, PBHs on the map, because we realized they could exist. And what was interesting about that was that it then motivated Stephen to start thinking about the quantum effects of these small black holes, because he realized that for small black holes, quantum effects would be important. And that led, actually, in the same year, to his discovery that black holes emit a thermal radiation with a temperature which is related to the mass and actually inversely proportional to the mass. Now, the mass is tiny for a solar mass black hole. It's about 1/millionth of a degree, so you wouldn't notice it. But for smaller primordial black holes, the time scale for evaporation could become very, very short. And in fact, any black hole which was smaller than roughly 10 to the 15 grams, which is the mass of a mountain, it's the size of a proton, would have evaporated by today. In fact, would be evaporating today. Now, that was, of course, a tremendously surprising result because people used to think black holes were black. But what he'd shown was that actually these small black holes aren't black at all. They evaporate due to quantum effects. And that's, even though there's still not definitive evidence for this, it was almost immediately accepted as being true because it was such a beautiful theoretical result. It sort of marries up relativity theory, quantum theory, and thermodynamics. And John Wheeler told me, this was such a, who coined the word black hole, once told me that this is such a beautiful result that even talking about it was like rolling candy on the tongue. Okay. And I think it was actually one of the most important results in 20th, certainly the second half of the 20th century physics, even though it's still not confirmed. But the reason I'm telling this story is because Stephen only came up with this result because he realized primordial black holes could exist. So even if primordial black holes don't exist, it was really important to think about them because it led to this great breakthrough in physics. And I think there's a more general point. You know, people get obsessed with whether theories in physics are right or wrong. I mean, theories can be useful, even if they don't turn out to be right. So even if primordial black holes don't exist, I would argue that it's been tremendously useful to think about them. However, since I've worked on the subject for 50 years, I obviously would like to think they might exist.
That was in the 1970s, but do we have any reason now to believe that primordial black holes exist? Is there any evidence for them or anything that we can look for? Because they do seem to be gaining in popularity as a research topic now.
What's remarkable is that you referred to the ups and downs in the popularity of primordial black holes. For the first several decades, it was a really rather minority interest. I mean, the number of people working on primordial black holes was really just dozens. And because there was no direct observational evidence for them, of course, there was a spurt of interest when Steam discovered Hawking radiation. And there was actually a hope that one might be able to see one of these black holes exploding, because I mentioned this mass of 10 to the 15 grams. So a primordial black hole of 10 to the 15 grams will be evaporating today. And for most of its life, it's sizzling around and generating 100 MeV gamma rays. But then at the end, as it radiates, its mass goes down, and eventually its mass goes down, the temperature goes up. So you get a process which culminates in an explosion when the black hole disappears. So when we were at Caltech together in 1975, the great hope was that we would be able to see one of these black holes exploding as a gamma ray burst. Because if that had been happening, it would, one, prove primordial black holes existed, and two, it would prove that Hawking radiation was correct, which would be tremendous important results and would have got Stephen the Nobel Prize, no doubt. However, the fact of the matter is that we soon realized that it was unlikely we'd see black hole explosions. And that's because most of their life they're generating these 100 MeV gamma rays. And we could see from measuring the gamma ray background, we put limits on how many primordial black holes there were of that mass. And that gave limits on the explosion rate. So it seems unlikely that we're going to see black hole explosions. But later on, and this, remember, was still in the 70s, later on, the interest shifted more to the black holes which are bigger than 10 to the 15 grams, which are not evaporating. And so now the interest is, well, what else can these big black holes do? Can they, in particular, provide the dark matter? You know all about the dark matter problem. We've known about that again from the 70s, really, the dark matter in galaxies, and even earlier than that, if you're talking about the dark matter in clusters. Since then, the most popular candidate for the dark matter has been some form of elementary particle, sometimes called a WIMP, a weakly interacting massive particle. However, there have always been other people who prefer the dark matter to be something astrophysical, in particular black holes.
So could the dark matter be any kind of black hole? Like the ones that you described that we already know definitely exist? Or would dark matter have to be related to primordial black holes specifically?
Ordinary black holes, stellar black holes, can't provide the dark matter because they form from ordinary matter called baryons, and we know the baryonic material can't provide the so-called dark matter. Primordial black holes were always possible candidates for the dark matter, and that goes way back to the early days in the 70s. However, this was a minority view. Since then, however, there's been a shift of emphasis to primordial black holes, partly because there's no evidence for the WIMP dark matter. People have been looking for a long time, the accelerators like CERN and in underground detectors, but there is no evidence, direct evidence so far, that the dark matter is in some particle form. I mean, there are lots of candidates, but there's no evidence for it. And so there's therefore been a shift to primordial black holes. But I suppose the main reason for the shift in interest is because of the detection of gravitational waves by the LIGO Virgo project in 2016. Because one of the surprising things about that, and we know that's correct because they awarded the Nobel Prize for the discovery, but one of the surprising things was that the black holes which were being detected, they could measure the masses. And the first black holes they measured, they were larger than expected. They were, I think the first ones were 230 solar mass black holes. And now they go up to 100 solar masses. So the black holes were bigger than expected if they'd formed from normal stellar collapse. And so people started wondering, well, maybe therefore they can be primordial black holes. And after all, the sort of black holes which would form at the QCD epoch, 10 to the minus 5 seconds. That's the quark hadron era. So they would have a mass of about a solar mass. And so people got interested in the possibility that these events being detected by LIGO, Virgo, and now CAGRA, maybe they could be actually primordial black holes rather than stellar black holes. Now, this is controversial. Most people would prefer to think that those black holes were the results of stellar collapse. And so that's the mainstream view. But there have always been people enthusiastic about primordial black holes do think that at least some of them could be primordial black holes. And if you look at the publication rate of papers on primordial black holes, it suddenly surged up in 2016 after that discovery. So, for the first 4 decades or so, it was a very modest number of papers on primordial black holes, a few dozen a year or whatever. Now it's hundreds of PBH papers, thousands actually. And for me, because I have to keep up with the literature, I have to keep giving review talks on the topic. It's a bit of a pain. I can't keep up with the literature. And life was much more interesting when no one believed in them. However, of course, on balance, I would much rather that primordial black holes exist. After all, I've worked on the subject for 50 years, and if they don't exist, I've wasted quite a lot of my life. No, not all of it, because I've worked on other things. But on the other hand, if they do exist, I'll have made an important contribution. But the strange thing is one has to wait a long time in physics before you discover, whether what you've done is worthwhile. I mean, it's 50 years after Einstein predicted black holes that we had to wait before we had evidence for them. We had to wait 100 years for evidence for gravitational waves. I actually think we will know within the next 10 years, because of studies from the gravitational wave events, I think we're going to know whether there are primordial ones. It will be unlikely that all of these LVK events are actually primordial, but I think some of them could be.
You've given us a taster of when primordial black holes started to come back into fashion after the discovery of gravitational waves. And what's interesting, I'll just note, is that obviously I'm a journalist, and when people were reporting that, it wasn't widely reported that there was any confusion or mystery about the mass of black holes. It's only through really talking to you now and looking at this kind of primordial black hole literature that I realized that there was all of this discussion going on. In the mainstream, it was just like, oh, we've seen black holes merge, gravitational waves, it's all great. The nuances weren't there. I'm going to take you back now, and it's not entirely unrelated. I'm going to take you back now to the 1970s. We're going to switch topics a little bit, back to the psychical side. We will come back to black holes because I know that you've got a lot of interesting ideas about them at the moment. So we will be coming back to that. But it's not completely different in the sense of thinking about the way things are reported in the media versus what it's like to be inside that story. And now I'm coming to this very big story from the 1970s, which was about the Enfield Poltergeist. And for people who don't know about it, you've mentioned there are movies, there are television shows about it. I mean, the Conjuring franchise, their second movie is all about this. It's all about the Enfield haunting. It was just so well known around the world. People came from around the world and visited this small house in North London. There's a family, there was a single mother who had, I guess, 2 daughters and 2 sons, but one son was away, but it was 2 daughters and 1 son living there at the time. And they started to report seeing furniture moving, flying around the room, objects being hurled, knocking sounds. At some points, there was talk of possession. The thing that's very, very famous, and how I sort of knew about it, was this idea that one of the girls, her name was Janet, at one point levitated. And this had been caught on camera. And I'll tell you, as I grew up and I heard about this was completely fascinating. And then I saw the photograph of her levitating. And I thought, does that look like a girl levitating, or does that look like a little girl jumping off a bed who's just been caught mid-jump? And so it became one of those stories. It's very, very famous. But there are lots of these stories about, there was a famous hoax in Britain where people thought there were fairies at the bottom of a garden that had been photographed. But it turned out to be 2 little girls had created some sort of pictures of fairies and photographed them. And people had got really excited about it. And I sort of thought of this story in a similar vein, that it's kids mucking about. I hadn't really looked into it very much. When I had looked into it, not very seriously, but I'd seen Sky made a drama about it at some point. And there were a few things that interested me about it. The fact that there were lots of witnesses, independent witnesses who had seen things, not just the family, neighbours, but also journalists, and also the police, which I think was probably one of the more interesting aspects, that the police had seen some of these phenomena and made an official report about it. But at the same time, I'm still thinking it's some kind of weird hoax or whatever. And then I'm watching this program on Apple. And as I say, I hear a voice that sounds kind of familiar, and it's Bernard Carr. And now my attitude changes because suddenly, for the first time, there's someone involved in this story, which was almost like a fairy story when I was growing up. But suddenly somebody that I actually know is involved with this story. And it's somebody that I know and I respect and I take seriously as a scientist. And that really shifts my way of thinking, because now I've got to weigh in and I've got a person to ask about what really happened. And it's somebody whose opinion I respect and somebody that I can trust. Now, I know that you weren't hugely involved with this case, but please give us a little bit about your experience at the time, what you knew about this, how you got drawn into it, and what your takeaways were.
I never knew, by the way, you came from Enfield, Zeeya. You've raised a number of interesting issues there. I mean, I'm very flattered that you should now take it seriously because I was on the program. I'm not sure that's a good reason, but that's an interesting point, because whenever you're talking about heretical ideas in physics, what makes them respectable is just one or two influential people saying, yes, we should take this seriously. So, for example, I talked about the anthropic principle and that being dismissed, but it only took a few eminent physicists, such as Martin Rees and Stephen Hawking and Steven Weinberg, just a few eminent physicists to say we should take this seriously. And then the field as a whole becomes much more open. Of course, you're talking about something much more specific about poltergeist, but it's a more general message that what makes subjects become respectable is just a relatively few number of people suddenly saying we should take this seriously. Even though there are thousands of physicists, it's just a few physicists who can influence the direction. But now let's get on to Enfield. And let's talk more generally, though, about poltergeists as a whole, first of all, because Enfield is just one example of a poltergeist case. It got a lot of publicity because someone wrote a book about it and there have been films about it. But of course, there's a whole history of poltergeist cases which goes back hundreds of years. And indeed, when I joined the Cambridge University Society of Psychical Research, one of our roles would be to go and investigate haunted houses or poltergeist cases. What's interesting about a poltergeist case is that it does involve physical phenomena. You see, if you go to a haunted house and someone sees a ghost, that does not need to involve any physical interaction. It could be in the mind. Now, of course, a skeptic will say a ghost is just an hallucination. It's not real. But you do have ghosts which are seen by many different people at the same time. It's what we call a collective apparition, as though it's really there. Or maybe the ghost will impart some information which you shouldn't have by normal means. But the point is, an apparition, it could be a purely mental phenomena. What's fascinating about a poltergeist case is that it does involve a physical interaction. It may involve furniture moving, it may involve somebody levitating. You mentioned that Janet levitated. It may involve fires starting, strange electrical behavior, lights going off, light bulbs breaking, floods, and all sorts of things. And that's what's, to me, so fascinating, because if it involves an interaction with the physical world, that means physics has got to be able to explain these things, if physics at least is going to be complete. Either that or you say that physics is incomplete, and that, to me, would not be a very popular conclusion. And therefore, you've got to decide, are these real phenomena? Now, the trouble with physical phenomena is that they can sometimes be reproduced by fraud. And in fact, the word poltergeist means mischievous spirit. And of course, the traditional naive view is that it really is a spirit which is behind it, some entity, some intelligent entity which is mischievous and just being irritating, like a little boy or something like that, or a little girl. However, the more modern view, which most psychical researchers would espouse, is that actually the poltergeist effect, the physical phenomena, is associated with a human being, not with a spirit, albeit unconsciously. And so the idea is that this human being is using what is called their psychokinetic ability. That's to say, the ability of their mind to affect the physical world. And there might be all sorts of psychological reasons for that. Often their adolescence, they're going through some form of personal trauma or stress, and that this in some sense is a way of getting out this energy, and it's coming out in the outside world, but very often unintentionally, without their even realizing it. But of course, saying it's psychokinesis rather than the spirit, it's still in the domain of psi, okay? Because it's still, most physicists aren't going to believe that the mind can affect a physical system. Now, I would claim there is some evidence that the mind can affect physical systems. Again, it's controversial. I would say even more controversial than telepathy. But I think there is evidence that the mind can affect, for example, random processes or even have macroscopic effects like making macroscopic objects move. But the problem with any poltergeist case is that you have to convince the skeptic that it really wasn't due to natural means. So if a chair is thrown across the room, you've got to ask, well, did someone actually pick it up and throw it across the room? Or was there really some unexplained physical interaction which was causing it to cross the room? You mentioned a picture of Janet, who was the girl who was involved, the prime focus of events here, levitating. And it's true, there are photographs of her levitating, but as you know, photographs can be faked as well. With AI now, it's even easier to fake things. So it's always difficult to assess these cases. First of all, you've got to have some way of recording the phenomena, and then you've got to make sure that the recordings haven't been tampered with. And then, of course, people see these phenomena, and it all comes down to the reliability of the witnesses. As you said, there were police and indeed journalists witnessed some of these phenomena. And so, in assessing a poltergeist case, it all comes down to how careful the investigation was, how good and precise the recordings were, and how reliable the witnesses were. And of course, you then have to decide, well, were these people, the children in this case, were they actually just playing around? Because they're called mischievous spirits, and children can be rather mischievous too. So there are undoubtedly cases in which poltergeist cases do have a natural explanation. I mean, there are lots of natural phenomena which can explain funny noises and movements in houses which don't require any psychic explanation. But here you have in Enfield, you have a case which is clearly either a genuine poltergeist case or children playing around. Now, I have to say, I only went there on one evening. I knew the investigators very well. I spent one evening there in 1977. I went with Tony Cornell and Alan Gould, who really were the most experienced ghost hunters, if you like, in the world. I mean, Tony Cornell was my mentor at Cambridge. He was the president of the Cambridge Society, and he got me even more interested in psychical research than I was before. He and Alan Gould wrote the definitive book about poltergeists. And although many of the cases had a natural explanation, some of them were indeed due to fraud, Tony himself and Alan became convinced that there were some fraction of them which were genuine. Not necessarily including Enfield, they only went to Enfield on one night. But I did go there on one evening, and I have to be honest, at the time, I didn't see anything which could not be explained by the children fooling around. So I had the impression at the time that it was probably a genuine poltergeist case, but that the children perhaps were mischievous and helping it along, especially when it started getting a lot of attention. But, you know, I only spent one night there, and I have not got a huge amount of experience in investigations of poltergeists like Tony Cornell and Alan Gould had. And so the investigators in this case were Maurice Gross and Guy Playfair. They were there for a whole year, and they were putting a huge amount of effort into recording events and interviewing people. And I've sort of changed my mind about this now. And I do tend to think it was a genuine poltergeist case. And as you will have seen the recent documentary, Apple TV documentary, which I thought was very good. That was the one in which I appeared. I thought it was very balanced because it put both points of view. On the other hand, there's no doubt that the Enfield case, it's very famous. It is the most famous poltergeist case, as you say, but it has been sensationalized. It was in all the movies, and some of the movies just don't relate to reality at all. I find what is so fascinating is that even after whatever it is, nearly 50 years, 45 years or whatever, one still doesn't know for sure. I still don't know for sure. I mean, I'm sure some people are completely convinced it's real. Some people will be completely convinced it was fraud. I tend to believe that it were genuine poltergeist effects simply because the amount of evidence and the amount of recordings. But I can't say I'm 100% convinced. In this field, in psychical research, I will never be 100% convinced of anything because it's so controversial. So I neither accept nor reject anything absolutely, but it was a fascinating case, and I'm very glad I went there for just for one. I spent just one evening there, but I'm very glad I did because we didn't know at that time it was going to become such a famous case.
I've seen dramatizations of the Enfield story on TV and at the cinema. The Apple documentary had an interesting format, mixing interviews. I think this was the first documentary that the actual family contributed to, but it mixed those interviews with reenactments of what had happened in quite an unusual way.
What was wonderful about this Apple documentary is that they reenacted my visit with Tony Cornell and Alan Gould, and they had the original tape recordings of our voices. And so when they reenacted it, the actors appeared, but they actually played the recordings. So the actors had to lip sync. It was fascinating. And I went to the premiere of the movie, and I met the person who played me in the documentary. And he said, yes, you had to acquire the skill of lip syncing and then sounding like somebody else. I thought it was a good documentary because it was balanced. That's what I liked about it. It had skeptics and it had the believers, the skeptics. It interviewed the people, the witnesses who were there. I suppose I was somewhere in between. I was trying to be the balance, trying to get a view somewhere between the complete believer and the complete disbeliever.
I should say, sadly, we're not being sponsored by Apple, but it is a very, very good documentary. And one of the reasons is, as you say, because they're using sound recorded at the actual time.
Yeah.
And it's not just about sort of having the reenactment with the actors, but when you can hear that sound and you hear the knocking and you hear furniture being thrown around, it's maybe don't watch it at night like I did with the lights off, because it can be it's that much more eerie and that much more scary when you know that this is actual sound, rather than you're in a cinema and you're watching what is clearly semi-fictionalized or maybe mostly fictionalized, sort of a version of reality. As someone from Enfield, I can say for sure that at the very least, the second Conjuring movie was highly, highly sensationalized. The denouement of the movie involves the house collapsing and some supernatural entities escaping dramatically into the street. I'm not actually old enough to remember these poltergeist events being reported in Enfield at the time, but I do think if something that dramatic had happened to a street and everyone had seen it, then more people in Enfield would have mentioned it to me. Anyway, thank you to Bernard Carr for that Halloween chat. Some terrific spooky stuff in part 1 of our conversation. In the next part of our interview, there's more on black holes and whether in some sense elementary particles can be identified with black holes, and Carr's ideas for a more complete theory of physics. And yes, of course, we will be covering more on the psychical side when we chat about some other cunning experiments that Carr devised to search for evidence of telepathy and clairvoyance, with maybe some positive results. And of course, I had to ask Carr, was he ever scared by his trips to haunted houses or going to investigate seances? If you are a fan of ghost hunting, I'll be adding links to more about the Enfield Poltergeist case, including a link to purchase Guy Playfair's book on the podcast page, qspace.fqxi.org/podcasts. And if you do purchase a book through one of our links or through the FQXI bookshop, FQXI will get a small donation. As I mentioned, we're not being sponsored by Apple for this, so every little amount that you give us can help. If you want to see photos of the house and Janet levitating, they're out there on the internet, but you can also find them on our socials. Look for FQXI or FQXI Physics and give us a follow. I will also be adding links to Bernard Carr's books, of course, on black holes and the multiverse. Plus, Miriam Frankel's 60-page review of the topic of fine-tuning and her podcast special on the subject. And if you missed it, our last couple of podcast editions featured cosmologists talking about the results of a survey from a black hole conference, which polled physicists on their opinions about primordial black holes, supermassive black holes, and controversial issues involving them. For more ideas about connecting consciousness to physics, it's also worth checking out some of the essays that have been entered to FQXI's latest essay competition, How Quantum is Life. The deadline for submissions has now passed, but you can still go and read the entries and vote for your favourites until the voting deadline of the 1st of December. And since I'm plugging books, in the first part of our chat, I mentioned that cosmologist Andre Linde had an interest in telepathy. You can learn more about that in my book, A Big Bang in a Little Room. That's all we have time for today. Thank you all for listening, as always, and please subscribe to the podcast so that you don't miss part 2 of my conversation with Bernard Carr. I've been Zeeya Merali.